So now we're going to start discussing the binomial theorem. So we're going to start with the definition. The sum of two terms is called a binomial. Here's an example. If I say a plus b, it's a sum of two terms, so we would call that a binomial. So our goal with the binomial theorem, we have the following goal. We want a formula for the binomial a plus b to the power n. So let's start looking at various values of n. So let's start with a plus b squared. Right, this is a plus b times a plus b. So here you would FOIL AA, AB, BA, and BB. So you would get a squared if you simplified these. These two terms would be the same because multiplication here is commutative. So you get 2ab plus b squared. So let's see what happens when we have a plus b cubed. Well, this is a plus b times a plus b squared. And we can plug in our previous calculation for a plus b squared. So this is, and I'm going to use the not simplified version here, AA plus AB. And then you need to distribute all of these terms out here. So distribute this a to these four terms and do the same thing with b as well. So here you're going to get AAA, AAB, ABA, and ABB. And then repeat that, but now distribute b out. So if I distribute b to these four terms, you would get BAA, BAB, BBA, and BBB. So this first term would be a cubed, and then let's look for our terms that have two a's in them. So two a's. There are three terms that have two a's in them and a b. Now let's look for the terms that have two b's in them. Two b's. So there are three of those. 3 ab squared and b cubed. Now here, like, we want to think about where these coefficients come from. So for example, this 3, well, really it came, if you look at the 3 that we have underlined, I have two a's and a b, and I arranged them in all the possible ways. So really, I place one b. I have 3 spots to place the 1b. So that's 3, choose 1, and then the a's have to go in the remaining spots. So this would 3, choose 1, a squared b. Now if I look at this one, I'm arranging an a and two b's. So I have 3 positions. I'm going to place those two b's into position, and then the a goes into the remaining spot. So when I'm counting these, it's really like I'm counting the number of arrangements here. Here I have 3 spots, and I'm going to place the 3 B's in those spots. Here I have no B's, so this would be 3, choose 0. So what we learned from this example is that these coefficients that are appearing here, when we expand it out, they are combinations. And so this leads us to the general statement of the binomial theorem. So here, n is a non-negative integer. A and B are real numbers. And then the formula says a plus b to the n. It's the summation from k equals 0 to n. The coefficient is n, choose k. A to the n minus k, b to the k. Or if you wanted to, you could expand this out. N choose 0, a to the n choose 1, a to the n minus 1b, n choose 2, a to the n minus 2b squared, until you get to your last term, which would be n choose n, b to the n. So this right here, this is our formula, or another way to say it is that this is our binomial theorem here.